There is a temperature at which a healthy adult, sitting in the shade, doing nothing, with unlimited water to drink and a fan blowing directly on their skin, will die anyway. It is not a high number the way you are picturing high numbers. It is not 130 degrees or 140. It is a reading on a different scale, one that combines heat and humidity into a single figure. And the threshold is 35 on that scale, which is 95 degrees Fahrenheit of what scientists call wet bulb temperature. Below that line, your body can still cool itself by sweating. Above it, it cannot. The air is already so saturated with moisture that sweat will not evaporate, and evaporation is the only cooling tool your body has left once the air around you is hotter than your skin. So your core temperature simply rises, hour by hour, until it stops. For most of recorded history, that reading has essentially never happened anywhere on Earth. Across the entire planet, wet bulb temperatures have only very rarely pushed past 31. The 35 threshold was, until recently, treated as almost theoretical, a line that existed in physiology textbooks, but not in weather stations. And then 2 scientists ran the models forward and found the first place on the planet expected to cross it. It was not the Sahara. It was not Death Valley. It was the coastline of the Persian Gulf. Doha, Abu Dhabi, Bandar Abbas, and Dubai. That is the detail that tells the real story. Because Dubai is not a city that stumbled into the desert by accident and got caught out. Dubai is the single most deliberate act of environmental defiance in human history. It is a city that looked at one of the most hostile climates on the planet and decided, with almost unlimited money, to out-engineer it completely. And the thing it was built to defeat is now moving faster than the engineering can keep up. Start with what Dubai actually is, because the scale of the defiance is the whole point. 70 years ago, this was a town of pearl divers and traders on a saltwater creek, with a population you could count in the tens of thousands, no paved roads to speak of, and summers that made the middle of the day essentially uninhabitable. There was no oil economy yet. There was no skyline. There was a hot, shallow inlet and the desert behind it. Today, Dubai is a metropolis of roughly 3.5 million people that has been engineered, almost in its entirety, around a single promise, that you will never have to be in the desert. You move from a cooled apartment, to a cooled car, to a cooled office, to a cooled shopping mall the size of a small town. And on the hottest day of the year, you can cross the entire city and never once feel the actual air of the place you live in. The Dubai Mall alone covers more than 12 million square feet. There is an indoor ski slope with real snow, kept below freezing, in a country where the outdoor temperature routinely hits 45 degrees Celsius. The whole city is in effect one enormous machine for holding the desert at arm's length, and for decades that machine worked so well that the desert became something you saw through tinted glass on the drive to the airport. But a machine that holds back an environment has a hidden assumption built into it. It assumes the environment stays roughly the same. It assumes the thing on the outside of the glass is stable, and the Gulf is not staying the same. It is doing 3 things at once, and every one of them attacks the machine at a different seam. The first seam is the one those 2 scientists found. The wet bulb ceiling. The research came out of MIT in 2015, published in the journal Nature Climate Change by El-Fatih El-Tahir, a professor of civil and environmental engineering, and his colleague Jeremy Powell. They ran high-resolution climate models across the Gulf region, and what they found was that by the latter part of this century, under a business-as-usual emissions path, cities including Dubai could exceed that 35-degree wet bulb survivability threshold several times across a 30-year period. A limit that El-Tahir noted had, as far as anyone knew, never been reliably reported anywhere on the planet. And here is the part that makes the Gulf specifically, and not just deserts in general, the danger zone. It is the water. A dry desert, paradoxically, is survivable at astonishing temperatures because sweat evaporates instantly and cools you. That is the Mojave the Sahara, brutal by the thermometer, but the humidity is low, so the wet bulb reading stays far below the lethal line. The Gulf does not have that mercy. The Gulf is a shallow, enclosed body of warm water sitting directly beside the cities, and under the summer sun, that water heats up and evaporates, loading the coastal air with moisture. So Dubai gets the desert's heat and the sea's humidity at the same time. High temperature and high humidity, stacked, which is the exact combination the wet bulb scale is built to measure, and the exact combination that kills. This is not a distant projection with no signal in the present. In the summer of 2015, at Bandar Mashah in Iran, just across the Gulf, the wet bulb temperature climbed to 34.6 degrees, a fraction below the line that is not supposed to be reachable. For an hour, on the shore of the same sea Dubai sits on. So the first thing the desert is doing is breathing humidity into a city that was designed as if the outside air would always, eventually, be something a person could walk through. There is a temperature coming for this coastline at which stepping outside for an afternoon is not uncomfortable, but fatal. And the entire premise of the city is that you can always get to the next cooled box before that matters. The premise holds right up until the power does not. The second seam is the opposite of heat, and it opened on a single day. On the 16th of April 2024, it rained on Dubai. Not a drizzle. In a period of about 24 hours, the city received 142 millimeters of rain. To understand what that number means, you have to know the baseline. Dubai's entire annual average is around 95 millimeters. The average for the whole month of April is roughly 8. So the city took, in a single day, close to a year and a half of its normal rainfall. It was the heaviest rain the United Arab Emirates had recorded in 75 years, going back past the discovery of oil to the very start of record-keeping in 1949. Inland, at Al Ain, one area recorded 254 millimeters, and the city built to defeat the desert had no idea what to do with water. Because why would it? A place where it never rains does not build storm drains. It does not grade its roads to shed water, or size its drainage for a flood, because the entire engineering imagination of the city was pointed at heat and sand, not at rain. So the water had nowhere to go. It turned the highways into rivers. It stranded Rolls-Royces and Aston Martins in brown floodwater up to their windows. It flooded the metro. It shut down Dubai International Airport, the busiest airport on Earth for international travel, and the disruption rippled through global air traffic for days. The damage was later estimated at between $2.9 and $3.4 billion. 5 people died in the way. In the aftermath, a story took hold that the government had caused it with cloud seeding, the practice of flying aircraft into clouds to encourage rain, which the UAE has run since the 1990s. It is an appealing explanation because it means the flood was a mistake, a switch someone flipped, something controllable. But the meteorologists were clear, and the truth is more unsettling than the myth. The storm system was forecast up to a week in advance. It was a massive natural weather event, and cloud seeding does not create storms of that magnitude out of nothing. What the science actually points to is that a warmer atmosphere holds more moisture, and when a storm does arrive over this region, there is simply more water available for it to dump. The flood was not a man-made error to be switched off. It was a preview. So the desert is attacking from 2 directions. The air is getting more humid, pushing toward a heat threshold the body cannot survive. And when water does come, it comes in a volume the city was never built to absorb, because it was built for the opposite emergency. Which brings us to the third seam, and it is the one that ties the whole thing together, because it turns the city's own survival strategy into part of the problem. Water, not the flood, the drinking kind. Dubai sits on a desert with no rivers and almost no rain. So where does the water come from? For 3.5 million people and all those fountains and that indoor ski slope and the golf courses laid across the sand, It comes from the sea. The UA, like its Gulf neighbors, depends almost entirely on desalination, the process of taking in seawater and stripping the salt out to make it drinkable. The nations ringing this one shallow gulf now account for something close to half of all the desalination capacity on the planet. But desalination has a byproduct, and the byproduct is the trap. When you pull the fresh water out of seawater, what you have left over is brine, water that is now far saltier than what you started with, often warmer, and carrying the treatment chemicals from inside the plant. For every liter of drinkable water produced, roughly 1.5 liters of this hot hypersaline brine is created, and it goes back into the same shallow enclosed gulf the city drinks from. The Wei alone is estimated to produce around 1/5 of the entire world's desalination brine, and it is all being discharged into this one body of water. The Gulf cannot flush it away quickly, because it is nearly enclosed and, at its deepest, only about 100 meters from surface to seabed. So the salt builds up. Parts of the Gulf are now believed to be around 25% saltier than normal seawater, with some stretches over 50%. Eltahir, the same MIT scientist behind the wet bulb research, also studied this, and found that brine discharge had raised salinity in the southwestern Gulf along the Arabian coast by a measurable margin. And here is where it becomes a trap rather than just a side effect. The energy required to desalinate seawater increases as the water gets saltier. So the more brine the city pours back, the harder and more energy hungry it becomes to pull the next liter of fresh water out. The city is slowly poisoning the well it drinks from and making its own lifeline more expensive to operate with every passing year. Now put that beside the cooling. Because cooling is the other half of the same machine, and it fails in exactly the same way. Air conditioning is not a comfort in Dubai. It is life support. Studies of buildings in the UAE have found that cooling can account for up to 80% of a building's entire electricity demand, and across Dubai as a whole, air conditioning makes up close to half of all electricity consumption, rising to as much as 60 or 70% of demand during the peak hours of a summer afternoon. The city has even built vast district cooling networks, central plants that pump chilled water through underground pipes to whole neighborhoods at once, because cooling at this scale is too fundamental to leave to individual units. But an air conditioner does not destroy heat. It moves it. It takes the heat out of the room and rejects it into the air outside, along with the waste heat from the electricity used to run it. Multiply that across an entire city of cooled boxes, and you get a machine that cools its inside by heating its outside. Research in hot cities has measured this directly. The waste heat from air conditioning can add a degree or two to a city's nighttime temperature, in the exact overnight window when the body most needs the air to cool down so it can recover. Do you see the shape of it now? Every one of Dubai's 3 survival systems has the same fatal design. The cooling rejects heat into the air, warming the city it is cooling. The desalination rejects hot brine into the Gulf, salting and warming the sea it drinks from. And the flood defenses were never built at all, because the city assumed the sky would stay empty. Each solution feeds the problem it was meant to solve. The machine that holds back the desert is, in its own exhaust, helping the desert close in. This is what the title means. It is not simply that Dubai is getting hotter, though it is. It is that the desert around Dubai is no longer the stable, predictable thing the city was engineered against. The sea is warming and evaporating, pushing the coastal air toward a wet bulb line the human body cannot cross. The atmosphere is loading with moisture that falls, when it falls, in volumes the streets cannot swallow. And the city's own defenses are accelerating both, warming the air and the water a little more each year in the act of protecting people from them. None of this means Dubai empties out next summer. It is one of the wealthiest cities on Earth. And wealth buys an enormous amount of adaptation. More power plants, better drainage, more efficient cooling, seawalls, redundancy on redundancy. The machine can be made bigger and stronger, and it will be. The question the city cannot buy its way out of is whether the machine can be strengthened faster than the conditions outside it worsen, when the machine's own operation is one of the things making them worse. So picture the edge of it. Out past the towers, and the cooled malls, and the highways that became rivers for a day, there is a pipe on the floor of the Gulf, a few meters down in that shallow, warm sea. And out of it, right now, in the dark, a slow plume of brine is spreading, saltier than the water around it, warmer than the water around it. The exhaust of 3.5 million people staying cool and staying hydrated on a coastline that was never meant to hold them. The water it flows into is the same water that heats under the sun and breathes humidity back over the city. The same water the desalination plants will draw from tomorrow morning, a little saltier than they drew from today. The same shallow, enclosed, warming sea that the models say will be the first place on Earth to cross the line a human body cannot survive. The city was built to beat the desert, but it was built